Welcome to Working with the Binomial. The way that we write that a random variable x is binomial is x is binomial, and we give the parameters n, the number of trials, and p, the probability of a success. So we can work with finding the mean and the standard deviation of a binomial. Now remember, for a regular discrete random variable, the mean is found by summing up each of the values of the random variable times the probability that that random variable occurred. And the standard deviation we would find as the summation of each random variable values minus the mean that was just found squared times the probability of that random variable occurring and taking the square root of that. But that was for any particular random variable. The binomial is special because it's a collection of Bernoulli trials where a random variable takes on values of 1 if what we see occurs and 0 if it doesn't. So in the calculation of the mean of a binomial, it's going to be a little bit different and far easier. So for a binomial, the mean is just n times p, taking the two parameters, multiplying them together. And the standard deviation is n times p times 1 minus p. So for example, if my random variable is binomial and the parameters are 10 and let's say 0.3, so the probability of a success is 0.3, the mean of this distribution is going to be n times p, so that would be 10 times 0.3, or 3. So my expected value for this random variable, where the probability of a success is 0.3, would be 3. And the standard deviation, n times p times 1 minus p, well, filling in my n's and my p's, that would be 10 times 0.3 times 1 minus 0.3, which is 0.7. And I would take this, multiply these two together, these three, 10 times 0.3 times 0.7, and I'd take the square root of that product. And I'd get the square root of 2.1, but don't forget to take the square root of 2.1. Don't just leave it as 2.1. That's the variance. The standard deviation would be the square root of 2.1, which is 1.45. So that's how we would find the mean and the standard deviation of a binomial random variable. Now let's look at a new example. X is a binomial random variable. The number of trials is 15 and the probability of a success is 0.37. First, we're going to find the mean and the standard deviation of this binomial random variable. Remembering that our n is 15 and our p is 0.37. So remembering that mu equals n times p, and replacing n with 15 and p with the probability of a success, which is 0.37, we can calculate the mean. So the mean of this random variable is 5.55. Now we can calculate the standard deviation. If we remember, that's n times p times 1 minus p, and then we take the square root of that. So in for n, I put n's value of 15. In for p, I put in its value of 0.37, and then 1 minus 0.37. So we'd have the square root of 15 times 0.37 times 0.63. After I multiply these three numbers together, I get 3.4965, but that's the variance. I want the standard deviation, so I have to take the square root of that number. So the standard deviation would be 1.87. Now, how do we find probabilities with a binomial? Well, we're going to use Minitab to find the cumulative distribution function, because those are like binomial tables in the back of the book, except for when we get them from Minitab, we can do probabilities of any type. So I could do 0.37, whereas most of the time we find that in charts we have things like 0.35 or 0.30, not 0.37. So we can be a lot more flexible with the probability of a success. So we're going to actually use commands to get the CDF, or the cumulative distribution, of this binomial problem. So I left click into the sessions window, and I hope you noted that that became a very deeper blue. If I press into the worksheet, that would become a deeper blue. But again, if I left click into my sessions window, it activates the sessions window, and the upper commands go with the sessions window. So I go into editor, I say show all commands, and in the right hand side I'll see the command line. To get the cumulative distribution functions, I type in CDF and a semicolon. A semicolon tells Minitab that I need to tell it some more information. I need to tell it that I'm in the binomial. So when I hit enter, after I've typed in the semicolon, I'll go into a Minitab subcommand, where I'm now going to tell it that I want to get the CDF of a binomial. So I write binomial, and I give the parameters of n, which was 15, and the p, which is 0.37. So that you can see that. And then I have to end that subcommand with a period so that Minitab knows, here, please do this for me. So I hit enter, and out comes the cumulative distribution function for this particular binomial. I can copy this by hitting menu and hitting copy, and I'm going to put it into my document here so that we can use it. So I have this cumulative distribution function that I'm going to use to find probabilities. Now, remembering that all these probabilities over here are not probabilities at these values of x's, they are cumulative probabilities, meaning that this number, like this number right here, that's not the probability that x equal 2, but the probability that x equal 2 plus the probability that x equal 1 plus the probability that x equals 0. So I can find easily any probabilities of x less than equaling a certain number. I would just go to the number that I see here. So if I wanted to find the probability that x is less than or equal to 7, I go to this line in my cumulative distribution chart and just read that probability off of there, because the probability of 0.85128 is the probability that x equals 7 plus the probability that x equals 8. The probability that x equals 7 plus the probability x equals 6 plus the probability x equals 5 plus the probability x equals 4 plus the probability x equals 3 plus the probability x equals 2 plus the probability x equals 1 plus the probability x equals 0. That's that number right there. If I wanted the probability that x equals 7, well, I have to think about that a little bit. If I take this number on the chart and I subtract it from this number right here, that will give me the probability that x equals 7. Because the probability of x equals 6, that's all of these numbers right here. So if I take the probability that x is less than or equal to 7, subtract off what I just put a line under right here, I would get the probability that x equals 7. So I look to my chart, I find the probability of x less than or equal to 6 and subtract less than or equal to 7 and subtract it from the probability x is less than or equal to 6, and I'll get the probability that x equals 7. So I take those two probabilities and I subtract them to get my probability that x equals 7. And that would be 0.15159. If I rounded to 4 decimal places, that would be 0.1516. That's how I find less than or equal to by just looking at the chart, and then to find the probability of x equal a value, I take that value that I'm looking for and just take that probability and subtract it from the probability just above it. So now let's take a look at the probability that x is greater than or equal to a number. So let's say the probability x is greater than or equal to 6. But I can't add all these numbers up together because these are cumulatives. This number has the probability of 6, 5, 4, 3, 2, 1 in there, and 0. And so all of these the same. So to find the probability that x is greater than or equal to 6, I need to take all the probabilities, 15, 14, 13, all the way down to 0, which would be 1, which would be this number right there, and subtract off of that all the probabilities less than or equal to 5, this number right here. Because this one contains all the variable values from 0 to 15. This contains all the variable values from 0 to 5. So when I subtract these two, I'll get all the variable values from 15 all the way down to 6. Exactly what I wanted. Which would look like this. And if I went to 4 decimal places, the answer would be that. Now let's see if we can take a look at what's going on also. In Minitab, if I go to Graph and I do my probability distribution, I want to view the probability. I make sure I'm in binomial with 15 for my trials, and my probability of an event is 0.37, and I go to shaded area. Now I'm looking for everything in the right tail that would be greater than a particular value. So I wanted everything greater than 6. I wanted all this in red, but the cumulative distribution only gives me everything in blue. And we know by our probability rules that 1 minus the complement gives us what we want. So 1 minus the probability in blue would give us the probability that is in red, which is exactly what we did here. We used our complement rule to find out the probability that everything is greater than or equal to 6. So now looking at an in-between statement, that means we want everything between 9 and 6, including 9 and 6. So we want everything less than 9, and greater than 6. So we would say probability x is less than or equal to 9, but that's too much probability by probability of 5, 4, 3, 2, 1, and 0. So we subtract that off. So we subtract off the probability of everything less than or equal to 5. So by looking at the graph here, I want everything, the probability between 6 and 9, those bars from 6 to 9. So the chart gives me everything less than 9. It's going to give me the whole left after 9. But I don't want these blue bars to the left. That's 5, 4, 3, 2, 1, and 0. So I just need to subtract off the probability of everything less than or equal to 5. And that's exactly what we did. So we put in our numbers. So we get 0.48205, or if we wanted to go to 4 decimal places, that probability of that occurring is 0.4821. I hope this brief and quick look at how to find probabilities with binomial is helpful to you, along with all the different help files I put up for you. Bye.